Okay, I welcome all of you to at another webinar from our Department of Aeronautical Engineering, KCG College of Technology. So I hope all of you, all the students, other than the external guests, if they have joined in, have enjoyed our webinars, which we have organized from time to time during this COVID, where the real online or physical classes are very difficult to engage. So in spite of the end of the semester and the lab classes and others going on, I'll appreciate all the students who have turned in and for this very interesting webinar that is organized today. Thanks to Dr. Kalaivanan, Head International Affairs, for organizing this. And I hope I will also welcome you formally from the Department of Aeronautical Engineering for like conducting this webinar, and from Department of Aeronautical for attending this webinar, and hope all of you have a good time. So our head of department, Dr. Vijayaraja, is not able to join in due to some he's attending another important meeting. So on his behalf also, I will welcome all the students, faculty, and other colleagues who have joined for this webinar. And I hope you guys have a very good time listening to Dr. Girupakaran. And before we start, I would like to ask Dr. Kalaivanan to give a formal introduction to the chief guest before we go into the webinar. Over to you.
Thank you.
Kalaivanan.
Thank you, Razar. It was like a brief welcome. And I'm really happy to introduce here Girupakaran Sivalingam. He is from Malaysia. So we just found in LinkedIn and we found that we both are from Manchester University. That's how we get connected.
Yeah.
And I was really happy to introduce him to our campus and to our students regarding the drone. Yes, he did his PhD in Manchester. Of course, that's not an easy thing. And he did most postdoctoral. He has been working, doing more than 4 postdoctoral, I guess. And then after that, the good thing is he went back to his home country, and then he is doing the job there, and he's working out in Kambyan network as head research and development from November 2018 to present, this past 2 years. And he's working in the project titled Drone for Oil Palm Plantation. So mostly it is an interesting topic to know about this drone usage of drone in farms and various things. And I'm really thank you that during the short period of time that you're ready to accept our invitation and being here and presenting and giving your knowledge to our students. I'm really happy to welcome you. So I guess now we give the stage to you, sir. You can start the presentation.
Thank you, Dr. Kalaivanan. Thank you, Dr. Sir. Guys, good evening to all KCG College Chennai lecturers and students. Okay, I think I prepared a short, very impactful, I think, presentation, so that we can, after the presentation, you will know there are key important things and you can remember. So I just want to make sure that these things are received by everyone. And then slight changes. I used to work in Kambyan. I know according to LinkedIn, I'm still working, but I also started my own company on the side called Sealbotics, which focus again on the drones as well. So I'll talk about that later as well. Okay, so the topic I took is the future of drone in farming. This is something, a new area. Farming is quite old, but the drone application of drone in farming is something, a coming up area. I think we can look into, especially in India as well, because it's one of the major, I think, farm producing country as well, I think, compared to all the other world countries. Okay, I will quickly go into the slides. So before going further into the drone applications, I would like to introduce first, what are the challenges being faced by farming sector recent years? So that will help us to identify what are the technology and why they are implemented and how it can be implemented. So one of the key thing is this world population is growing. I'm sure these need to be agreed by everyone. Based on the prediction from World Government Summit, by 2050, the percentage of the population will grow by at least 33%, which is about, from now, is about 7 billion, will raise up to 10 billion. And then by 2100, it'll reach at least 11 billion. So that was the sort of, they were saying that on the low side prediction, actually by actual fertility rate, they are predicting it to be more, at least hit about 16 billion or 50 billion more. So what it means by 2050, if it's indeed 10 billion populations are surviving in this world, then the world will need at least 70% more food to be produced by farmers. This is a huge increase. And then how are we going to meet this demand is the key questions everyone is trying to answer from all over the sectors, not only farming, agronomics, economics as well. So this is one of the challenges faced by the farming sector now. And the second key issue is the uses of natural resources are highly stressed. Highly stressed means, in a way, you plant in a certain area over the years, and if you don't take care of that area properly, after certain years, let's say 10 years, you can't grow anything anymore in that area. So they have a prediction that almost 25% of all farmland is already highly degraded, and almost 44% is moderately or slightly degraded. So this means eventually we need to find more new areas to establish the farming area plantations, or we need to do something, tackle these issues by some other method, so which I'm going to introduce later. Okay, and the third challenge, as this is, I think climate change is, everyone aware of it, global warming is happening. So this means is the way the weather behaves nowadays is very different from how it used to be. The sun rays are different, the way it rains and the wind blows all differs. So this means it affects the productivity of agriculture. Remember last time, I think in Malaysia, they have cycles for paddy fields. They do 4 cycles every year, and then they will predict when to plant the seeds based on these weather climate predictions. And since now it's different, and it affects the yield production because it rains more, it rains less. I think this is very common in Chennai, in Tamil Nadu, India as well, right? Which affects the yield. It means it used to give, let's say 1 acre of paddy field used to give, let's say like 1 ton or 2 ton of paddy rice. Nowadays it's only giving 1 ton because of the climate change. So this is like it's another challenge because the populations are increasing and but the productivity is reducing, so we need to find more lands to plant, and more area deforestation happens, and that leads to various issues as well. So these are the 3 key areas that problems are faced by farming sector in recent years. So what's the solution? So this is the few solutions which has been categorized into 3 categories by World Government Summit. So World Government Summits, and just a brief introduction about them. So they give key advice or predict and then advise governments all around the world on how to tackle these sort of global issues. So that's where they're coming from. And so based on these 3 categories, you can see the first one is produced differently using new techniques. They use hydroponics. Hydroponics means they plant the trees on the water, bioplastics, and another method, and algae feedstocks. So these are like some countries may practice, but I'm not sure whether the Asian countries is applicable to do this. And they have other options are desert agriculture and seawater farming. This is like way in the future. They are it's like a science fiction movie, but it may happen, it may not, depends. And the second one is the category is the use new technologies to bring food production to consumers, increasing efficiency in the food chain. Because a lot of food are getting wasted because it's not, or is being oversupplied to certain area, undersupplied to certain area. And also, so in order to tackle this area of problems, they are suggesting vertical and urban farming. I'm just going to go through these briefly because the key area I'm going to focus is the drone technology next, which is, if you see the 3rd category, so incorporate cross-industry technologies and applications. So that's where I'm coming now, actually. So in order to solve these issues, they have highlighted that we can't rely on the olden technologies. till now. So we have to look into new technologies. So one of the new technologies the World Government Summit is stressing on is the drone tech, as you guys can see. And then the second one is Internet of Things and precision agriculture and data analytics. So these four components are sort of like they interrelated. So I will explain why later. And so obviously you guys are from aero background. I'm sure you guys know about drone technologies, and Internet of Things is that they attach all the sensors everywhere, and everything is connected to the cloud. So all the data is received by these things. You can calculate and measure all the properties. So you can do some data analytics using that, and then achieve precision agriculture. So I'm going to address and focus on these two technologies, which is drone technology, and give a brief introduction about precision agriculture throughout the presentation after this. So brief intro to what is precision agriculture. In short form, they call it PA, or also they call as a smart agriculture or smart farming. And also some people, they call it as a digital agriculture. These are the key upcoming areas that you guys need to look into or study more about it. So PA is in a form, I'm going to read through actually, so because make sure everyone understands. So an approach to farm management that uses information technology to ensure that the crops and soil receive exactly what they need for optimum health and productivity. So in a way to give more explanation about this, what they are claiming, I mean the agronomics who study about plant and soils and those things, they are claiming that now people are not just spraying the fertilizers, putting the pouring waters to plantations and area based on just, they call it carpet method. So this much of area, they somehow predicted or follow the previous traditional method, and then they just put this much of water, this amount of fertilizers and those things. So that not specific to the ground or the soil or the plantation. So this means each plant may or may not need the exact, may or may not receive the exact necessary amount of what they call it, parameters like the nutritions to produce the highest yield. Yield means highest productivity. So some get wasted, and some area it doesn't get enough nutrition, so they don't produce much. So in order to solve this issue, so they introduced these three components, which is smart sensing and monitoring. It means we sense and monitor how much we put into the ground or the soil, okay? And then use that information to do some smart analytics or analysis or planning. It means to verify whether how much we put, is it necessary or do we need to put more? And then using a smart control, it means some sort of machine or automatic robots or something, we sort of close this loop. If it's more, we remove. If it's less, we put more. So that's the overall idea of precision agriculture. Actually, to tell the truth, the precision agriculture has been there for the past, I think, 10 or 15 years. Before that, they call it green revolution. After that, precision agriculture was introduced. But the problem is some level of smart sensing or monitoring is done, and they do some agronomics are there, and then they predict this much of soil or this much of, nutrients need to be put, or you need to control your water levels or how much intakes and those things. But the problem is that they don't have the smart control system, which means there's no robotic solution at the end to control or to measure how much we put into the soil or the plant and these things. Because now they use man and ask them to, suggest them to do this, but some does. In Malaysia, this happens. Just to give an example, they call it oil palm. I'm not sure whether you guys have seen oil palm. Something similar to palm trees, and something it produces. I will introduce later, like coconut, non-coconutty, fruity coconut bunch, and that's where they produce oil, which has been vastly used for in so many areas. So palm oil is a big industry sector in Malaysia. In these things, so there are vast lands, thousands of acres around the country. And usually the management will be at the entrance of that estate or the plantation area. So they will ask usually foreign workers will be doing this. So the agronomics will plan and pass this information to supply or pour this much of nutrition or water in certain trees or certain area. But in those areas that's near to the management office, things will be done properly. Further inside, further into rural plantation area, they won't do properly because at the end, man errors there, human errors are there, and men get lazy. They just dump something somewhere. You can't validate that they have poured or they have supplied the necessary nutrition. So that's where a robotic solution is needed, and we believe in Kambyan, or like I call Silbotics, that a drone would be the ideal smart control mechanism to close this loop. So that's where precision agriculture comes into play in today's topic. Okay, any questions so far? Dr. Kalai, shall we?
Yes,
Anyone having questions can either type it in your chat window, or you can like unmute and ask. I think it's better we have all the questions in the end.
At the end of the session.
Okay, sure. Then I'll just go ahead. Okay, the face is good, right, Dr. Kalai? I'm just checking. Am I speaking too fast or? I can't hear you. Sorry.
It's going good. I mean, it's going in a good pace.
Okay. Because sometimes I tend to not speak very fast. Okay. So what are the areas we can implement drone tag, or where the future, the guys are predicting that the drone tag will be useful, and how it can be implemented in plantation areas or farming or agriculture sectors. So one of the first, this has been started already in various countries and even Asians nowadays, soil and field analysis. Soil and field analysis means this is before the plantations, what they call it, not harvesting, planted, or before they if it's a paddy field, before they spread what they call it, the bijibani is the seeds. So they will use drones and carry these sensors. They call it multispectral or hyperspectral sensors, which actually produce multiple rays wavelength of lights, and then it measures back what it receives. So based on the different wavelength, it correlates, certain wavelengths correlates to certain soil parameters or field parameters. I will give some example later. And these sensors, just to give a rough idea, it weighs about 1 to 2 kgs and cost about, sometimes it goes about, there are a few cheap ones up to 2,000 USD. Some cost about even 10,000 USD. It depends on the accuracy and how many number of hyperspectral sensors are, the wavelengths are there. And then they'll mount this on a drone, and then they fly it across this field in a aerial mapping pattern, go forth and back, and then they'll map it up. As you can see on the left ground, it produces something like that. I'll show the results later. And then they correlate these to soil and field parameters. Sometimes the irrigation, so water content, water levels in that land, or nitrogen levels in that land, or different values. So to give an example, so these are the results, actually a sample result of NDVI. NDVI is a nutrition index, which is done using a multispectral sensor. So the left one is the actual image that you get after the drone run through the farm. And then based on these results, actually they will analyze, and then you can produce the result, the outputs, as you can see on the right, calcium, magnesium, and potassium. How this is done is a lot of papers are there. That agronomics correlates the wavelengths reflection to certain nutrients content like calcium, magnesium, and potassium. So based on these, they can map out how much the soil has like a calcium level, or what is it high, low in certain area, or certain magnesium level, potassium level. Sometimes they look into the what was it before? Nitrogen, nitroxide, something. So based on this information is useful to plan out where are the areas need more nutrition, or where are the areas need less nutrition, and then they can plan it out. So they can eventually make all ideal or all the same, but it's hard to do that. But at least they can try to reach an aspect or plan, if they say they want to plant in certain area only, to make sure where the ideal area they can plant more seedlings there rather than focusing throughout the land. So this is one of the key area that drones are being used. And in the future, they're looking into precision agriculture, where they can correlate every, let's say, every 10 centimeter square area, then you can have a nutrition content of that plot. And then you can correlate where to plant the tree, or where to plant the seedlings, rather than spreading throughout the area. Okay, second option, I think this is quite famous and everyone knows about crop spraying or fertilizing, or any other area, any other, how to say, area that requires a drone to fly and do something, spread or spray, because the spray can be fertilizer or chemical, or they call it a weeding spraying, which is like is a chemical, hazardous chemical to kill the weeds. So these are used there's a lot of drones out there, DJI. There are a lot of variety of drone from China, especially with cheap ones that can do spraying. And I think nowadays, especially in paddy field, people have started using this to do the spraying rather than the man going to the ground and spraying certain areas. And by actually using the drone to spray, you can make sure that throughout all the areas the spraying is done equally. And then you can make sure you can even do, if necessary, certain area based on the previous data, the soil sensing, you can loop the cycle and spray more or less in certain areas. So that's where the future is heading actually. So now people are doing carpet spraying using even drone, but the future look into spraying, using a spraying drone, which is precisely spray according to the GPS location of the drone. So we spray more, maybe 100 milliliter certain area, or 110 milliliter in certain area, and where is these acid flies. So that's where people are looking into. And the same thing as spreading drone. Spreading drone, it means it's because some forms of fertilizer are not in liquid form. They are in what they call it, granular form. They use this spreading drone to do the to spread out the fertilizer around the area. Or even I think in paddy, they use this to plant the new what they call it, nursery plants. Like they call it kannu solluvaangala andha mari. So that's something. These are the another area. I think it's commonly now available all around the world. And then precision. Just the missing part or the future part would be the precision components, so to precisely spray or precisely spread in a certain area. That will be something to look into in the future. Okay, next, this is something quite high tech, I would say, planting. I've seen a few videos going around Facebook and then coming around in future in certain tech magazines and everything. So there's a startup, I think the first one started from Europe or something, where they came up with the idea to use a drone to plant trees to fight against deforestation. So they come up with a capsule, and then this capsule contains plant seed, tree seed. So this is not the agriculture plants, these are just the forest plants, but actually the same method can be used for agriculture as well, if necessary. So it has a capsule, and then these capsules, or they call it pods, shoot to the seed from certain area, certain distance using the drone. And just to give an idea, I'm going to play the video. There's a video of it. But before, okay. So there's the overall idea. Let's come back to the slide. Okay, so and then and few other startups have started doing the same thing as well, and this could be a way method to fight against deforestation. And if there are big ones, because the thing, I'm not sure all the plantation where they're not like big ones like palm oil, they don't actually plant the seedlings straight away to the actual area. They grow these seeds in the nursery and only bring it to the actual plantation area. So maybe not necessarily this method will be applicable there. But I think India, if they want to implement this sort of technology, that'll be a great idea as well. Okay. Another area that drone can be used is crop monitoring. So remember previously we used a drone to carry the multispectral, hyperspectral sensors to analyze the soil. And similar multispectral sensors actually can be used to analyze the plant once it has been grown on the field. And also any aerial imaging can be processed. The RGB image can be processed to process and determine where the weeds are. And also the sizes of the plant. So they use mainly monitor to the sizes of the growth. So certain areas may have slow growth, certain areas can grow well. So they can identify this in the early stage and then to determine and to tackle, highlight this issue and to solve the problem. They can identify what are the problems and then they can run NDVI analysis on that soils area and then solve the problem rather than waiting for the next 3 months or 4 months and then they end up getting less yield. And then also weeds, they can identify which are the area weeds are more, and then you can spray the chemicals more in that area rather than spraying the chemicals throughout all the areas in the carpet spraying method. So that's one idea. And then this right image shows an example of analysis on a plum tree orchard. So they detecting, this is one type of, I think, disease or pest control, chlorosis. So based on the NDVI analysis, they can identify which are the area that's been affected by this chlorosis and then they tackle and to implement pest control to avoid this problem. So this will be helpful for them. They call it this as a method scouting. It's like scanning throughout the plantation area, identify where the stress levels are high and then which plants require treatments and then plant growth and more. There's a lot of things can be done using this method based on the type of plantation. So here for oil palm, we use this method to determine, because most of the oil plantation, they experience pest diseases in terms of they call it bagworm disease, which happens on the tree of the plant. They turn yellow, so they can detect this early stage and then prevent that because it's spread fast. So if you can routinely do this aerial mapping using sensors, like monthly once or 2 months once, and you can predict early and you can prevent that from spreading throughout the 100 acre or 1,000 acres. That's one of the area. Okay, just to give an introduction, what are the example sensors out there that can be used with drones and softwares as well. So Atlas is one of the model of Mika Sense. And then they can be used to detect weeding and the chlorophyll levels in plantations. So MikaSense is one of the, Atlas is one of the guys, or leading guys that have been producing these are sensors in this area. And then another, I would say, is the cost-wise a bit cheaper is the Centra. These sensor modules weighs from few hundred grams to few 1 kg or 2 kg. So the variety of sensors you can choose based on your need and based on your drone size to implement these sensors to produce NDVI or NDRE. They call it. It's a different variation of aerial imaging. And then the other one is the DJI Zenmos. DJI Zenmos is just a normal camera, but the drone deploy is another, I think, well-known software to do aerial mapping, aerial sensing. It can be used for a lot of variation of drones, DJI, Pixel, or the variety of China drones as well. Okay. Okay, those are the key methods of the area where the it's like a general idea where the drones can be used to help plantation or farming issues now and also in the near future. But at Sivalingam, so Sivalingam is a subsidiary company of Kambyan, and we focus more on the R&D part and the drone developing specifically for palm oil plantations. So this is what we are doing, just to give an idea what we are doing now and where we are, what are our visions to achieve in the near future, and how we're going to implement the drones in this sector. So something like a case study or case sample. So palm oil, this is what palm oil looks like, and the right one is, they call it on top is the fruit bunch. So inside the fruit bunch they have these small fruits which they process to in a factory to produce some sort of oil or like a buttery stuff. It can be used almost in all the stuff we use on a daily basis. In these things, we are interested to automate the process involved from key processes involved in palm oil plantations. So mainly is spraying. So spraying, we spray fertilizers. We also spray what they call it chemicals to as pest control. And second is harvesting. So harvesting is to cut the fruit and then to bring it down. And collecting means because how it is done nowadays is that a guy will be going around to cut the tree and then cut the fruit, and then the fruit bunch will be left underneath the tree, and then there's another guy will be going in to collect the fruit bunch. So that's another tedious process as well that we would like to automate. And transporting, because as I was saying before, our plantations are vast and big, and then the processing mill is far away from certain areas. So transportation is another key area that we would like to highlight, because a lot of issues are involved in transporting this harvested fruit bunch and then bringing them in time to be ideal, they call it optimum time to be processed to produce the oil extraction. Okay. So these are our vision. This is a lot of information are there in a single page actually. So I'll go from the top corner left, HAIL. So HAIL is high altitude, long endurance drone. Because if you see almost all the drones and all the sensor modules, they have to be connected to internet to transfer the data. And and most of the plantations, the oil palm plantations, are in rural area where the connectivity is poor, or you won't get any connectivity. So that's where we are working with NASA's, I think it's a subsidiary company or agency, which they are developing this high altitude long endurance drone, which can fly at, I think, 5,000 feet or something. And it can carry a GSM module to provide connectivity to about a 400 kilometer square area. So any drones within that area can be connected to internet, and to enable all these drones to transfer data and to be controlled by a HQ command center. So that's where on the right top of corner, you can see a command center controlling all these multiple platforms. Okay, and then if you see on the left, there's a drone called Quantix. So this is a vertical takeoff drone. We use these drones to do the soil analysis and also the plantation crop scouting or analysis. So it carries the NDVI, the multispectral sensors or the hyperspectral sensors, and fly 2 days once or 3 days once to scout around the plantation area, and then send the image on time to the cloud and to the command center to be processed. And after that, you can see that there's an imaging drone. This is a standard drone. You can get it from DJI. We use this to do regular aerial mapping to which that aerial mapping will be, the map will be used to plan the planting of the trees and certain areas, certain things. And then there's other ones, there's a few other drones that we envision to be achieved with the near future, which is the collector. It's just a conceptual idea. Basically it's a drone with an arm to collect fruit and then to pass it to a transporting drone. And next is, you can see there's a sprayer, and then there's a sensor drone. Sensor drones is something like we can implement sensor modules to measure, because from aerial imaging, the hyperspectral and NDVI sensors, you won't be able to measure certain parameters of the soil. So there's idea to implement sensor modules on the ground, and we fly a drone around this area, and then it can be connected wirelessly and transfer the data. I mean, from the sensor module to sensor drones to collect the soil data as well. And then finally, we have a transported drone. So transported drone basically just collect carry all the fruit and transport the like a 1 ton or 500 kg of fruit to the mill. So it is going to be a bit bigger ones, a huge ones. So to give a rough idea how these things may look in the future, we came up with a video. Let me play the video. Rewind. So in this video, actually, it shows a coconut plantation. So the drones are brought in by AGV. It's auto-guided vehicle. So that's a transporter drone. So we call this as a harvester drone, which initially there was idea to use a sharp, they call it, what is it, hyper vibrating or something cutter. But eventually now we changed to a laser cutting drone idea. I agree that it may look like a far-fetched concept or idea, but we are actually working towards that keenly. And then let me go back to the slide. So that's the overall idea we have in mind. We would like to achieve in the next 2-3 years, actually. But certain concepts have changed. Something like, as I said, harvester drone, we changed from the cutter to a laser cutter, and then certain portions it will be handled by human for now, and then eventually it will be automated, fully automated system will be used. Okay. So this is where we are now. So we developed a laser cutting drone, a POC, a proof of concept drone now already at Kambyan Steel Baltics. So it has a 3 degree of freedom arm, and it is a compact laser module, and it actually tested on a DJI. But I'm going to show an example. Actually, this is one of the video that we taken from our demo. So let me play that frame from now. So this was the, we did this in the exhibition. So this is just to give a rough idea how it's going to look and how it's going to work in actual environment. We have created actually it's a foam holder. It's something similar to the they call it, what is it? The branch of an actual palm tree, but with a different thickness. That's the key difference. So the drone is actually searching for that part. The branch bottom section, and then aiming to, so okay, it turns on the laser and then it fires. So there's it's a POC, proof of concept. We have some analytics to detect where to cut and where to initiate, and how the laser should be controlled to achieve the cut, and it knows that the fruit has been cut, and then it comes back. So this AI part is done, and the POC part is done. So the idea is actually, I'm going to play it again. Eventually scale up the drone, scale up the laser part. We're already working on that now. And then we can use a similar AI controlling system to achieve the same results as what they've shown here. Okay, go back to the, sorry. Okay, so that's where we are now. There are a few things certain things are confidential. I can't really reveal everything. But I would say there's an exciting area. If you guys are interested, that you should further, because I believe there's really a good future in using drone for agriculture, and then especially in Chennai, India, the application can be big, and then I'm really keen to see some India-based drone models, and then used in-house, and something like similar to China. Okay, that's all. Thank you.
Thanks, Dr. Girupakaran. It was a very nice webinar. I believe all of them enjoyed it. And yes, as you say, like drone technology is is obviously changing the way that we live, not just in farming sector. I think it's intruding in many sectors, like your drone taxis, and of course, like in military sector, it's been there. Yeah, it's been there in the military sector for a long time. But now in the civilian sector, I think, of course, mapping and tracking, and maybe for spying, even for household security purposes, CCTV. Also, you can think about drone things. So I think we've got a couple of questions here already. So if anyone else wants to ask any questions, I think you can put it in the chat window. We'll try to answer it. So the first question is from a girl called Soumya. She wants to know, can a drone detect any bird entry? Because birds and animals mainly destroy the crops that are in a farm sector. So is there any way for a drone to detect a bird or an animal?
I think detecting a bird or any animals is quite straightforward actually. But the thing is that when they enter, the drone should be in the sky. So when to launch the drone? So because most of the off-the-shelf drones, their flight time is only 20-30 minutes. So if you have, but there are this a new area, I think that I should have included that. They call it hybrid drone, where they combine an engine with battery, so it can fly for 3 hours, 2 hours, and it has a good payload of 5 kg or 10 kg. If those type of drones can be deployed, it can fly continuously guarding a certain area, then it may be able to use to detect birds and an animal or even intruders. Actually, the AI is there to detect intruders like a man, something. Sometimes this happens in Malaysia, palm oil sectors. They use there's some breaching by outsiders to not to steal the fruits because they can't process it. Obviously, they steal the machineries that we use to manage the plantation. So this happens. Even they can be used to detect that. I think that's how I would say is that drone is actually is an enabler. As long as you can know the camera guys or the camera analytics guy, they can come up with a program to detect this. And then if it's the weight and the power consumption is good enough, if it's something anything weighs about less than 2 kg and it consumes moderate power, it can be used with drone. So that's how these things works. That's why drone is going into all the areas and being used vastly in so many sectors. So I would say it can be done, but the only thing is that can we exactly fly the drone when there's a intruder by the animal or the bird? So how to detect that would be the question to answer.
Yeah, there's another question. So I think that answers it. Like the next question from Nitya Kalyani Singaravelan. Like she wants to know, she is developing a project on agricultural drone and also an Android app to operate it with some advanced features like 3D imaging of the crops, thermal sensors, seed throwing machine also.
That's good.
She's ready with the concepts. She wants to develop a prototype. So she wants to know how to proceed and what she needs to do. And is there any specific technology to improve the feature of a project?
Okay. That's a good question. So there are, okay, so depending on your, how to say, expertise or your experience developing or in drone related technology, you can choose the areas to or model to work with. So I would suggest two models. So DJI drones, they have certain SDKs. So, and then they have variety of platforms as well. The one that being used vastly for I would say for research and R&D was they call it M100, DJI M100. Then you can they provide SDK, means is what they call it, a software development kit. So you can develop your own software and integrate that with the drone, and then you can achieve what objective that you want to do. Or rather than using DJI, because DJI, when you use DJI, you're bound to work with certain type of platforms. Another open source platform is, they call it PixHop. Let me Google and show. I'm not sure whether you guys have used this.
No. I think they're all bachelors only. Can you just clarify, Nitya Kalyani, what are you doing?
No. I'm gonna share the screen with to show what I mean. Sorry. So PixHop. Okay, this is a quite stable platform. Okay, so this is an autopilot. So, and they why I would like to suggest that this PixHop, they call it PX4, or you can Google it as a, what is it? That's the name of this one. Okay, PX4 autopilot. Okay, PixHop. Can you guys see PixHop here? Okay, so they have a proper documentation. That's the interesting part. Is, can I see? Okay, so they have a to Z detailed user guide on how to implement these control. This is like the brain of the drone. How to use this and how to, and based on the application that you want to use it, how to program this SDK. You can integrate that with the ROS. ROS is another robotic operating platform. Or any other ground control stations, you can, or simulation models, you can integrate, they have A to Z guidelines on how to use this model to achieve what you want. So I would say this would be a great platform for students, aero students, or those interested in drone to learn. And it's something like they have a lot of forums and thread, and you can post questions. They will assist you from all around the world. So this would be like putting your own booms, developing, finding own motors and then attaching them, and you can make it fly. And if you really know how to do that, and then from that, I think you can do whatever you want actually.
Yeah, we have one more question. I think that could be the last question. We can wind up after that. So Mr. Akash wants to know, like the drones, when you use it for agriculture, it will require a large time for operating. So obviously
Yes.
the cost will be higher because you need maybe a bigger battery or a bigger size, or like cost will go up naturally. So how do you tackle this and how to make it use effectively?
Okay, that's the thing. So from I can give some example from Malaysia, actual use cases. So let's say let's for spraying nurseries in oil palm plantation. Let's say it's a 20-acre nursery. They'll have about like 10 guys spraying this regularly. 2 weeks once, 1 week once, something like that. But if you use a drone, you can achieve the same, you can cover the same area faster, but just using one pilot and one co-pilot. So to compare the price comparison wise, rather than paying 10 people about 1,500 ringgit, which is about like 300, 400 USD per month, you can just pay a little bit more to these two guys, and then you can achieve the same results or even more better results. Okay, and that's how they can cover the cost over a time period, not necessarily on the first month itself. Over 6 months, they will get the ROI. They call it what is the rate of return of interest, or how much they put in, and then they can start making money after a certain 1 or 2 months period. And then another thing that in Malaysia, actually, we are looking into why it's good to implement this sort of method. I mean, using technologies to do farming. Because most of the Malaysians, I'm not sure whether it's India, how it works. They went to college, they get a degree. They're not willing to go back to do farming jobs anymore. So that's where Malaysia mostly rely on foreigners, mostly Indonesians and Bangladeshis, to do this hard works actually in the plantation area. But by bringing in this technology, if you bring in, rather than manual spraying, you use a robotic spraying, a drone spraying, you can, like Malaysians are interested, I mean our locals are interested to go back to the field because they get paid properly, and they can claim themselves as a drone technology or drone guys rather than just a farmer, and then they can achieve more, and then they can, at the end we get the same results actually. So in a way, this helps our locals as well. I don't know whether this can be applied in India, how the scenario is there.
Basically works out to be the cost. Basically, it works out to be how much cost cutting does it bring? I mean, is it going to replace the manual labor? Those questions will be there.
It will replace manual labors, and it can bring in more money. So that's been proven here. But I'm not sure how that's something you need to look into before applying any technology to any area. If the manpower cost is very low, then it's quite hard to bring in this technology just straight away. But sometimes, if you look into the concept of precision agriculture, come again, Dr. Sir?
Yeah, maintenance cost, like other than the capital cost, there will also be added maintenance cost, right? So that also needs to be taken into account. Maintenance.
Yeah, maintenance cost. Maintenance cost. So that's the thing. So if you just substituting manual labor to spray by a drone, maybe not enough. You need to bring along the precision agriculture. It means by bringing in this technology, it may cost more, but eventually it produces more yield. Yield means the same area produce more tonnage of either if it's paddy rice. So in that cycle, you can cover the cost. Sometimes there's a reason, I would say, that these sort of techs are easily implemented in overseas because the manpower costs are very high there compared to Asian countries.
India.
But so we need to really look into areas and the cost study before actually implementing these sort of technologies. Yeah, I would agree with that.
I think that's enough. Like we have had a very good webinar followed by I think very interesting questions, 3 or 4 questions. We have very kind of Dr. Girupakaran of answering that as well. So I hope his expertise and this was very useful to all the faculty and students who have attended this webinar. And overall, I believe it's a very good, pleasant. I mean, it's a very exciting times that we are living in, especially in this COVID time, and also the drone, how it can play a role. Maybe drones can help in the COVID scenario as well, because if there are many, avoid the social distancing. I mean, keep the social distancing, avoid crowding, etc. as well. So in that way also it might help. So I would like to formally thank Dr. Girupakaran for accepting our invitation and
welcome. Thanks.
Yes, thanks, and also
thanks for the opportunity. I'm very keen because I've given webinar to different countries, UK and US. This is the first time I'm giving to Tamilians, so I'm quite happy actually. So thanks for the opportunity. So we should discuss more whether there's any area that we can look into, work together, or any advice. So I'm very keen to actually collaborate or something. So
sure, we are happy to hear about it.
Thank you.